Hey guys, so this is lesson 7-9 and it's the homework for it. Okay, so I'm going to start on number 1. It says tennis balls are sold in cylindrical cans with the balls stacked one on top of the other. A tennis ball has a diameter of 6.7 centimeters. To the nearest cubic centimeter, what is the minimum volume of the can that holds a stack of 4 tennis balls? Okay, so I'm just going to kind of draw a picture so that we can get a scenario here. So 1, 2, 3, 4. And a can. Okay. So this is, I don't know if you've ever bought tennis balls before, but this is kind of how it comes. They come in like a can. I always thought it came in 3, but they're saying 4. So anyways, it says a tennis ball has a diameter of 6.7 centimeters. So that means if we kind of look at one tennis ball in there, this is 6.7 that way. So that's going to help me to get my radius. So if the diameter is 6.7, then your radius is going to end up being half of that number. So if you do 6.7 divided by 2, you get 3.35. Okay, so they're just saying what's the minimal volume of the can that would hold it. So they just want the volume of the cylinder. So we have the radius of the cylinder because it's going to be the radius of a ball. We have to figure out what the height is. So if you kind of think about it going this way, the height is going to be equal to 4 diameters added together. So 1 diameter, 2, 3, 4. So in other words, if I do 4 times the diameter, that's going to give me the height. So 4 times that 6.7 gives you 26.8. So with your volume formula, volume of a cylinder is pi r squared h. So it's pi times, we said the radius of the cylinder would be the 3.35 squared. And then the height is 26.8. So this will give you approximately 945, or choice 4 as your final answer. Okay. So then number 2, I think we may have seen number 2 before. It talks about the Great Pyramid of Giza. So they're telling you that it was constructed with a volume of 2,592,276 cubic meters, and this is its height. They want to know the length of one side of the base. Now, they did tell you it's regular with a square base. So in order to figure out the big B, you're thinking of it as length times width, but length and width are the same. So to start this problem, the first thing you want to do is to write your volume formula. So volume of a pyramid is 1/3 big B times H. So they're giving you volume, so I'm going to put that in there. The 2,592,276 would equal 1/3. Now, I'm just going to keep it as big B for right now. I just kind of find it easier that way. So to get rid of this, the first thing I did is I kind of did 1/3 times 146.5. There's a lot of ways you can solve this. You can multiply both sides by 3 and then divide 146.5. I just figured combine these terms together first. So 2592276 is going to equal, it ends up being 48.83 repeated times big B. So you divide it out. So divided by that 48.83 repeated. Okay. And you end up getting that the base area of this pyramid is 53084.15017. So if that's your base area, you need to figure out 2 numbers that multiply to give you that, right? So in other words, I want this 53,084.15017 to equal L squared, I'll call it, or you can call it X squared. So I'm just going to square root this number, and you end up getting 230 would be the length of one side of its base, or choice 4. Okay, so then for number 3. So it says, as shown in the diagram below, a regular pyramid has a square base. Okay, so label that 6 and 6, whose side measures 6. If the altitude of the pyramid measures 12, its volume in cubic inches is what? Okay, so they're giving you altitude. Altitude is the same thing as height. So they're telling you guys that that's 12. So this is a very straightforward question. So volume is going to be 1/3 big B times H, or 1/3 of length times width times height, or 1/3 of 6 times 6 times the 12, and that's going to get you 144, or choice 2. Okay, you guys can turn the page. Okay. Now, some of those questions we may have seen before, but a lot of these now are going to, I mean, this one I think we actually may have done in class already, but it's fine. So it says the diameter of a basketball is approximately 9.5 inches and the diameter of a tennis ball is approximately 2.5 inches. The volume of the basketball is about how many times greater than the volume of the tennis ball? Okay, so the first thing you want to do is you want to kind of separate it for the basketball and for the tennis ball. So the diameter of the basketball is 9.5 inches. So if that's diameter, the radius is going to be half of that. So half of that is 4.75. So half of the 2.5 diameter is going to give you a radius of 1.25. So you're going to break this up in terms of the basketball. Okay, so starting with that volume, I'm going to do, since it's a sphere, it's 4/3 pi r cubed. So it's going to be 4/3 pi, your r is 4.75 cubed. Again, make sure that 4/3 is in parentheses, times pi times 4.75 cubed. You end up getting 448.9205002. Okay, so then you do the same thing for the tennis ball. And I'm going to call that V1, by the way. So then tennis ball, I'm going to call it V2, is going to be 4/3 pi r cubed again. And this time I'm going to put the radius of 1.25. And you end up getting 8.1821230,869. Okay. So if you want to know how many times greater the basketball's volume is than the tennis ball, you just divide the two numbers. So V1 divided by V2 is going to get you your answer. So you end up getting 55 times greater in terms of volume. Okay. Now, number 5, when it came out, because this was actually on a June exam, so I kind of remember the results, they're telling you, here's inches, this is feet. So you have to remember that you actually have to convert this to inches before you do anything. So the easiest way to do that is if you have 25 feet and you have 12 inches per foot, just do 27 times 12. And that is actually 324 inches. So you can imagine that people forgot to do that when it first came out. So I'm sure one of these answers is if you left it as 27. So the first thing I'm going to do is I'm going to find the volume of this rectangular prism at the bottom. Then I'm going to find the volume of this half cylinder on top. So let's start with the volume of the rectangular prism first. So volume of rectangular prism. Okay, so that volume formula is just length times width times height. Or if we look at this question, the one thing to keep in mind is that this height right here is going to be half of the 2.5. It's going to give you 1.25. So we're going to end up having 2.5 times the 1.25 times the 324, and that gives you 1012.5 cubic inches, right? Because everything's in inches. Okay, so that's that volume. Then we have to find the volume of half cylinder. Okay, so it's going to be a half of pi r squared. H. Okay, so I'm going to have 1/2 pi. Now, if we look up here, the radius of this circle is going to also be that 1.25. So it's going to be 1.25 squared. And then the height of the cylinder is that 324. So you multiply those together, you get 795.215640 cubic inches. Okay, so then your total volume equals your V1 plus your V2. And that gives you 1808, or choice 3. Okay, kind of a lot going on there, but that was pretty much the only two tricks to this problem, is that you had to convert those feet to inches and then kind of recognize that the radius would be the 1.25 and that the height of that prism was the 1.25. Okay, so then number 6, this one says, the pyramid shown below has a square base. Okay, cool. A height of 7 and a volume of 64. What is the length of a side of the base? So it doesn't matter what you guys want to call the side of the base. So like, for example, you can call it L and L, you can call it X and X. I'm just going to call it S and S as for sides. So your volume formula for a pyramid is 1/3 big B times H. So they're giving you guys that the volume of it is an 84. So we don't know big B yet. We're going to leave the area of the base as just B. We do know the height's 7 though. Okay, so we have 7. So what I did is I just did 1/3 of 7 first, just multiplied 1/3 times 7. Again, you can multiply both sides by 3, then divide by 7. You'll get the same answer. So I got 2.3 repeated B times big B, and I divided it out. And you end up getting that the base area is 36. So what two numbers multiply together to get you 36? We'll think of it as 36 is equal to S times S, or S squared. So if you square root it, you get 6. And a lot of you probably could have just did that in your head. So that's one way to go about it. The other way is, since they're giving you examples of sides, what you could have done is done a guess and check kind of method. Put 6 in there and then just multiply it out. 1/3 times 6 times 6 times 7. Did that give you 84? And it should. Okay, so that's for number 6. So let's turn the page. Okay, now number 7 is a new type of question. It kind of puts together rotating two-dimensional figures into 3D solids. So it says a rectangle whose length and width are 10 and 6 respectively is shown below. Okay, the rectangle is continuously rotated around a straight line to form an object whose volume is 150 pi. Which line could the rectangle be rotated around? Okay, so there's no good way to approach this problem except to kind of work out each one. The first thing I want to look at, though, is kind of look at what they did give. So they gave me that I have a volume of 150 pi. So when we rotate a rectangle around any one of its sides, it doesn't matter. It's going to end up giving you a cylinder. So if we look at the cylinder volume first, the formula. Volume formula is V is equal to pi r squared H. Okay, I know that this is 150 pi for volume. So if I just kind of simplify what I can simplify, I can divide out pi on both sides. So I need the radius squared times the height to equal 150. So in other words, I don't need to figure out the volume of every single one. I just need to focus on that property. So I'm going to start with number 1 first. So say I rotated this rectangle, and I'm going to actually draw it for you guys. Say I rotated this rectangle and spun it around the long side 10. If you guys remember, what you do is you do a reflection first, and then any point not on there is going to spin in a circle. So I need 150 to equal r squared times h. So my r in this example would be a 6. My height would be 10. So this would be, does 150 equal, this is going to be 36 times 10 or 360? No, it doesn't. So choice 1 can't be an answer. Okay, so this was choice 1. So choice 2, then it says rotate it around a short side. So if you rotate it around the short side, so I'm going to draw it again. It's going to be reflecting over this way this time. And then it's going to spin around. So 150 has to equal my r squared. My r is going to be 10. And my height's going to be 6, right? This is your r. This is the height of the cylinder. So does 100 times 6 or 600 equal 150? No, it does not. Okay, so it can't be choice 2. Okay, so then it says for step 3, kind of running out of room, but it says the vertical line of symmetry. So vertical meaning going up and down. So if you were to put a vertical line of symmetry in the rectangle and then spin it, this side will reflect onto that side and vice versa. So it's going to look like this. So your new radius is actually going to be 5. So is 150 equal to, let's see, we would have 5 squared times the height of 6. So 25 times 6. And what you guys will see is that does in fact equal 150. So your answer is going to end up being choice 3. Now you could have done it this way too. Then it would have been 3 squared times 10, which would have been 900. So that wouldn't have worked out. Okay, so in other words, the answer is choice 3. So then for number 8, it says, when volleyballs are purchased, they are not fully inflated. A partially inflated volleyball can be modeled by a sphere whose volume is approximately 180 cubic inches. After being fully inflated, its volume is approximately 294 cubic inches. To the nearest tenth of an inch, how much does the radius increase when the ball is fully inflated? Okay, so again, we're going to split this up into 2 separate parts. We're going to look at partially inflated and then fully inflated. Okay, so here's our formula for a sphere. It's 4/3 pi r cubed. Now they told you that when it's partially inflated, the volume is 180. So I'm going to put 180 in here. My goal is to solve for r, and I'm going to be doing the same thing over here. So I have 4/3 pi r cubed. I'm going to be doing the volume of 294 on this side. 4/3 pi r cubed. Okay, so in order to solve this, there's a lot of different methods. Probably the easiest method would be to divide out 4/3 pi on both sides. Now, when you divide it out, you have to make sure that 4/3 is in its own set of parentheses and pi, right? So it kind of looks like this. So parenthesis, parenthesis, 4 divided by 3, close it, times pi, close it. So divide this out in your calculator. Make sure you can actually get that answer. You end up getting 42.97183,463. Okay, that's not the only way to do it. You could just multiply both sides by 3, then divide that number by 4 pi, and then that would be your answer also. I just think this way is faster. Okay, so then to get rid of a cube, like something cubed, you cube root it. So if you guys forgot where that is in your calculator, I'll show you guys real quick. You click the math button right here. So you click math, and then it ends up being like choice 4. So you write cubed root, and then you would type that number in, 42.97183,463. Okay, and that's where I'm getting this number from. Okay, so again, it's at the math button, number 4. So you end up getting 3.502632975 is your R. Okay, so then doing the exact same procedure on this side, divide by 4/3 pi, 4/3 pi. You end up getting 70.18732999 is your R cubed, and then cube root it. And you get 4.124958406. Okay, so when it was partially inflated, this is what the radius of the ball was. When it was fully inflated, this is what the radius was. So they want to the nearest tenth of an inch, how much does the radius increase when the ball is fully inflated? Okay, so I just have to then subtract the two numbers. So we're going to do 4.124958406 minus 3.5026329975. And you end up getting 0.622325431. So that to the nearest tenth would be 0.6 of an inch would be your answer. And again, they don't take off if you didn't write inch. If you just wrote 0.6 as your answer, they would accept that. Okay, so then turn the page. So for number 9, it says the greenhouse pictured below can be modeled as a rectangular prism with a half cylinder on top. The rectangular prism is 20 feet wide by 12 feet high by 45 feet long. The half cylinder has a diameter of 20 feet. To the nearest cubic foot, what is the volume of the greenhouse? Okay, so this is a pretty straightforward volume question. So the first thing, I'm just going to call it V1, V2. So we'll call the top V1, this V2. So the volume for V1 is going to be half of a cylinder. So 1/2 times pi r squared h. So the radius is going to be half of this 20. So it's going to be 10. The height of it is the height from base to base, or 45. So when you guys do 1/2 times pi times 10 squared times 45, you get 7,068.583471. So then you do the same thing for the rectangular prism, which would be a length times width times height, or 12 times 20 times 45, or 10,800. So your total volume then is V1 plus V2. And you get 17,869, which is choice 1 to the nearest cubic foot. Okay, number 10. So it says Randy's basketball is in the shape of a sphere with a maximum circumference of 29.5 inches. Determine and state the volume of the basketball to the nearest cubic inch. Okay, so if you just start finding the volume of a sphere, the only thing that goes into that formula is the radius. So in order to complete this question, we're going to use the fact that they gave me circumference to find the radius. So circumference formula is 2 pi r. So they gave you that circumference as 29.5. So that's going to go in for C. So then your goal is to just solve this for r. So the easiest way to do that is just divide both sides by 2 pi. And again, don't forget when you do this in your calculator, 2 pi is a grouping. It's an operation between them, so you need parentheses around it. So multiply that out or divide that out, and you get 4.6950700821 is your r. So in your formula, that's all you got to sub in. So 4/3 pi times 4.6950700821 cubed. So they want this to the nearest cubic inch, which means whole number. You get 434 cubic inches would be your answer. Okay. So then we have number 11. So number 11 says, Ian needs to replace 2 concrete sections on his sidewalk as modeled below. Each section is 36 inches by 36 inches and 4 inches deep. He can mix his own concrete for $3.25 per cubic foot. How much money will it cost Ian to replace the 2 concrete sections? Okay, so the first thing that's the problem is that the cost is in cubic feet. So right now they're giving me units in inches. So right now it kind of makes sense to just make sure all of this is all in inches before I start. Or I'm sorry, in feet, because that's what the rate for the cost is going to be in. So down at the bottom, it's pretty easy to do. You could set up conversions as if it makes it easier for you. So you know that you have 12 inches in 1 foot. So if you're trying to convert 4 inches to feet, put inches with inches. And then if you're trying to find feet, put X with the 1 foot. So if you guys cross multiply this, you get 12x is equal to 4. Divide both sides by 12. And you get 1/3 foot. Okay, is going to be this length right here. So this is 1/3 foot. So then you only got to do it once for the 36. So same thing, 12 inches over 1 foot is going to be equal to 36 inches, right? Inches with inches over X. So you get 12x is 36 divided by 12. You get X is 3 feet. So it's 3 feet by 3 feet by 1/3 foot. So if you want the volume, it's going to be length, width, and height multiplied together. So 3 by 3 by the 1/3 gives you 6 cubic feet, right? Because this is 9, or I'm sorry, 3 cubic feet. So you end up getting 3 cubic feet. Now, they said that how much will it cost to replace 2 concrete sections? So if this is one of them, I have to multiply it by 2 to get the volume for 2 of them. Okay, so this is how much cubic feet he has to like replace with concrete. And if it's $3.25 per cubic foot, you're going to multiply $3.25 by that 6 cubic feet, and that's going to be your cost. So you get $19.50 would be the cost to replace the both of the concrete feet. Okay, so then turn the page. Okay, so then number 12, it says a bakery sells hollow chocolate spheres. The larger diameter of each sphere is 4 centimeters. The thickness of the chocolate of each sphere is 0.5 centimeters. Determine and state to the nearest tenth of a cubic centimeter the amount of chocolate in each hollow sphere. Okay, so we're going to have 2 volumes that we're going to look at. We're going to look at the overall like sphere, and then we're going to look at the hollow part, and then we're going to subtract the 2. So to find the volume of the first part, where it just says the larger diameter of the whole thing is 4, so that should be pretty easy. So I'm going to call that V1. So that's going to be 4/3 pi r cubed, and I'm doing 4/3 pi. Now if it's 4 centimeters, I'm just going to half that number, so right for radius. So you end up getting 33.51032164. So then you have to find the volume of the hollow part. Now when you think of the sphere, think of like the 2-dimensional cross section. It's kind of easier to think about. So this is the whole thing. This whole thing is 4. If you have like an inside hollow part in there where it's only 0.5 centimeters thick on both sides, you're losing 1 whole centimeter. So this inside diameter then ends up being 3. So when you do your second volume with 4/3 pi r cubed, you're just going to have to half the 3 to get the 1.5. And this gives you 14.13716694. So in other words, I'm taking the whole thing and taking away the part on the inside. So it's going to be my V1 minus V2, and that to the nearest tenth gives you 19.4 centimeters cubed as your final answer. Okay. So then the part 2 of this says the bakery packages 8 of them into a box. If the density of the chocolate is 1.308 grams per centimeter cubed, determine and state to the nearest gram the total mass of the chocolate in the box. Okay, so first off, let's just kind of look at our units here and make sure everything's in the right unit. So to start, they're giving me density. They're saying density is 1.308 grams per centimeter cubed. I just found volume of the chocolate was 19.4 centimeters cubed. So this is actually good. Right now we're doing pretty well because we have centimeters. So this is a mass question. That's the only variable left over. So I'm just going to do density times volume. And I'm going to do that 1.308 grams per centimeter cubed. And you end up getting 25.3752 grams. So that's in one of them. So they want to package 8 of them. Like, so you have to times this number by 8 and tell them how many grams you would have to the nearest whole gram. So you would have 203 grams. Okay. So that's that one. So then the last one, I'm not going to lie, is kind of hard. So it says, Shay has recently begun kickboxing and purchased training equipment as modeled in the diagram below. The total weight of the bag, pole, and unfilled base is 270 pounds. The cylindrical base is 18 inches tall with a diameter of 20 inches. The dry sand used to fill the base weighs 95.46 pounds per cubic foot. To the nearest pound, determine and state the total weight of the training equipment if the base is only filled to 85% of its capacity. Okay, so in other words, we're going to figure out the volume. Like, so they already told you that the bag, the pole, and the base being empty, weighs 270 pounds. Okay, so the whole goal of this is they want us to determine the weight of all of it with that 270 plus filling this to 85% of its capacity. So the first thing we got to do is figure out the volume of the base when it's all the way full, because right now we're going to end up having to figure out 85% of its capacity. So the volume formula for a cylinder is pi r squared h. So I have pi times the radius of my base is 10, the height is 18. So I have 5,654.866776. Now, right now, my volume is in cubic inches. So there's two ways to approach this problem. I'm going to show you guys a way I haven't showed you yet, just because I don't want you guys to get pigeonholed into one way to do things. So what you could do to do this problem is convert the inches to feet right off the bat. And you're going to get decimals, you know what I mean? But you could definitely do that, and then you won't have to do what I'm about to show you. But this is another way that actually works also. So right now my volume's in cubic feet. So the first thing I got to do is also figure out 85% of this number. So I can do that very easily by doing 85 divided by 100. Okay, and then set it equal to x over my total, that 5654.866776 cubic inches. Okay, so if I do that, I end up getting, when I cross multiply, you get 4,806.63676 cubic inches. Okay, so this is what's kind of weird that we haven't ever showed, or I haven't showed you guys how to do it yet. If you want to convert, so converting cubed inches to cubic feet, okay, you can take your number, so that 4,806.63676 cubic inches over x. Now, think about it logically. If you have how many feet that are in, how many inches in 1 foot? You have 12 over 1. Now, you can't leave it as 12 over 1, though, because this is one-dimensional. Like, you're just talking about a length. So if it was area that we were talking about, we would do 12 squared over 1 squared. So since this is converting a volume to cubic feet, you have to do it to 12 cubed to 1 cubed, and then cross-multiply that. So whatever 12 times 12 times 12 is going to be the number up here over 1. And that's going to be the ratio that you can convert it to. So when you cross multiply this, you get 1728x is equal to 4806.63676. And then you would divide it out. So you end up getting 2.7816189495 cubic feet is what it is in now, right? Because like this was cubic inches over cubic feet. So that's just another way. We've never actually done that. If you go online, you can see model responses where kids do this. So to avoid this, though, you could just convert in feet right away. I always try to say it's easier, I think, if you actually convert early. But this is just another method, because if you want to convert inches to like feet cubically, remember that the side to volume ratio is a cubed to cubed for the sides. Okay, so that's why we end up getting that number. Okay, so then we have to look at the, let's see, the next thing that we're going to do is the pounds. So they want to know, determine to the nearest amount of pounds that we can convert to. So we're going to put our number 2.78161845. This down a little bit. Cubic feet over x. And we have to convert it to pounds. So it weighs, like, so it says it weighs 95.46 pounds per cubic foot. So for every 1 cubic foot, they're telling you that it weighs 95.46 pounds. So this is going to give me my, if I cross multiply this, it's going to tell me how many pounds I have. So you end up having 265.5333016 pounds. So this is how much the sand would weigh in the bottom of the weight. So we still have to remember that just the bag, the pole, and the base, which was empty before, was 270. So we're going to add these two numbers together, and then to the nearest whole pound, that's going to be my answer. So you get 536 pounds would be your final answer. So again, this is a different method. We've never seen this before, but I think it's kind of good to know that if you did want to convert cubically, like a cubic inch to a cubic foot, you have to actually do the ratio 12:1, and you have to actually cube that ratio. So say we were doing areas. So if it was areas over like a square area over feet squared, you have to do 12 squared over 1 squared, or 144:1 would be the ratio that you do to cross multiply to convert it. Okay, so that's it for this lesson, guys. So check over that homework, and you guys will have the next lesson coming up.